So just real quick, I'll go to the end. If you have these answers, then you correctly did this problem. All right, we got 0, 3.45, 8.44, and 4.37. What I want you to do before we go any farther, though, I'll work through, like, in extreme detail this problem because I already did, like, most of you did fine. Some of your issues come from balancing. I saw at least 3 people today that just didn't balance right. And that's a heartbreaker because you can do all the math, but everything's wrong because you don't balance. Now, the good news there is the way this test is written, it's written in parts. So, like, if I see that you got one of these wrong, you'll miss a couple points for that. Now, this is right, by the way, but you'll miss a few points there. But if you do the rest of the test correctly, but with the same wrong numbers, are wrong, but I'm going to give you full credit. You just lose parts for this. Does that make sense? Yay, Diane. All right. Then, the way to solve for the limiting reactant, we'll just remind you. Oh, no. There we go. Is you set up 2 picket fences. The picket fence start with the 2 different givens, but they solve for the same unknown. This year, I think that part has sunk in really well. In previous years, I've had lots of kids that solve for the 2 different products, and then that screws up everything royally. So you start with your 2 reactants. You solve for one of the products. Now, this class, as I walked around, almost everyone in here converted it to A, B, C, and D, and no one in first hour did, so I must have taught completely different. I love the A, B, C, and D method. I would use it myself. Just double check when you write your answers, you put the right answers in the right spot. That's all. Right off the bat, you might want to come down here and just put your A, B, C's, and D's right here as well. Does that make sense? Just to help you not screw up. All right, coming back. So we did 2 picket fences. One had 18, one had 8. So we eliminate the one that is bigger. And we now know 2 answers of the 4. We now know that our limiting reactant is AgNO3, which means there's 0 grams of that. Don't get that wrong, please. And we also know the answer for AgCl is 8.43. So we're all right with that so far? And you would scribe those in at the end. The next part then is to solve for one of the other 2. So we already have solved for these 2. So now the easier thing is to find the other product that was produced. So every picket fence you start with starts with the limiting reactant. You have 10 grams of that, and you're going to solve for grams of the other product now. So we just picket fence it. I noticed 2. They wrote the 2 right there, but they didn't type it in their calculator. Those things hurt my feelings because I have to make you lose points even though you had the right process. Anyway, you type this in and you end up with 4.37. And then that's one of your answers. So you would now have 3 of the 4 answers. You'd have this one, this one. If you get this part wrong but the rest of them right, you can still get like 90% on this test. So it's not a disaster. But finding the excess reactant is typically the hardest part. To find the excess reactant, we set up a picket fence where we start with our limiting reactant and we work our way to the amount of excess reactant that is used. Okay? So we take the 10 grams and we convert it to grams of MgCl2. This is ugly, but that says 2.8. All right? I think it was this 2 also that was forgotten. We do this math, and remember that means 2.8 grams were used. We go to the original problem and we find that you had 6.25 to begin with. We subtract the 2.8 and we're left with 3.45 grams of MgCl2 excess. That gives us our fourth answer that we plug in right. It was that one, right? Right there, and we are ready to roll. Hopefully you feel pretty comfortable with these. There's only one of them on the test. This piece of paper that you're looking at is the test from last year. I'll give it back to you after I sort of look at them on my prep hour. It will be different numbers. It might be different formulas, but it will be the exact same process. So if your paper is all green, then you should feel ready. If it's mostly green, you're mostly fine. If it's mostly red, you really need to watch every single class video that I've posted. You need to come into B time, get some extra help. Come early if you want, before school. That's the best time to find me, and you'll be set. All right, the rest of the hour, we're going to switch and talk about what we talked about yesterday. Let me pause this. Fine, I'll go one more. Okay, so the idea behind combustion analysis, it's kind of cool. It's when in doubt, light it on fire and just see what it makes. What we have, and this is an easy one, it does not contain oxygen. We just have something that's C and H. We know we're going to burn it, which means we're going to produce CO2 and H2O. The genius behind combustion analysis is that if you can find the amount of carbon dioxide, the only place this C could have come from is where? Over there. And the only place this H could have come from in water is over here. So if I can keep track of the amount of carbon dioxide produced and the amount of water produced, I can solve for the amount of C and the amount of H. And if I can have moles of C in a ratio of moles to H, which is just math, that will tell me my numbers that go right here. They're just a ratio to each other. That's what a formula is. So are we all right with the idea of this? Silence means yes, except for this time it means I don't know that that's a yes. Okay, well, Diane gets it, so I'm sure everyone gets it. Okay, so the first step was to convert grams of CO2 to moles of C, correct? All right, so I have 4.4 grams of CO2. And what do I want to solve for? Moles of C. We'll do that when we do combustion. All right, so this one's a shorter picket fence that we've been doing. And just real quick, look at the screen. You were okay when A plus B went to C plus D, and you could do a picket fence. But if I have CO2, there's no reason I can't say it goes to C plus O2. So please look, for every 1 mole of carbon dioxide, I have 1 C and I have 2 O's. Are we okay with that? Actually, I should have just put it this way, sorry. 2 O's. So don't worry when I break this up. That is completely legal. So here we go. There are 44 grams of carbon dioxide for every 1 mole of CO2. And then I just told you a proportion. For every 1 mole of CO2, how many moles of C are there? 1. It's just the subscript. 1 mole of C. And then I'm ready to roll. I just take 4.4 and divide it by 44. And what does that equal? 0.1 moles of carbon. Good so far? Okay. Step number 2 is to repeat this process, but now we're going to convert grams of water to moles of H. Now, I'm going to erase all this just so I can stay on the same place, but you have this number. Remember that number. So I'm going to take 2.7 grams of water. And I'm going to convert it to grams of H. Now, a lot of times kids don't like this because we're having H alone, even though we know it's diatomic and there's a 2 there. But just when we break these up, we're looking for just the atom itself. There we go. So there are 18 grams of H2O for every 1 mole H2O. And for every 1 mole, whoops, this is not grams, sorry, this is moles. Oh, shoot. Oh, I hate when I make mistakes. This is moles, not grams. For every 1 mole of H2O, we have 2 mole of H. And we do that number. That one I can't do in my head because it was easy like the last one. What's that number? What's that? 0.3. Okay, so now I know that my moles of C equals 0.1. My moles of H is equal to 0.3. The next step was to divide all answers by the smallest answer, which is 0.1. And this would give you a 1, and this will give you a 3. And these numbers now tell me my coefficients in my formula. This compound consists of CH3. That's it. That's the what? This is the empirical one. This problem does not give you more information because honestly, CH3 does not really exist. Really, what this would say in the problem, it would say the mass is really grams. And you would say, okay, this adds to 15, but it needs to add to 30. So then you would double everything. See, this compound really would be C2H6. But we don't have to be there yet. Like, that's coming. But that you don't have to be there yet.
How did you get 44?
I just added them. It's 2 H's plus 1 oxygen. It's from the periodic table. 2 plus 16 is 18. How many of you understood what I just did, like, reasonably? Like, I don't expect it to be crystal clear. Okay, tomorrow we'll spend the entire hour on combustion. It's not as bad as you think. It was just thrown at you before you were supposed to get it, so that's why it seems bad. I do want your worksheets and your periodic tables. I'll move this pile to the back. On the way out, you can just leave them there. You done?
Yeah.
Sorry, hold on.
If I was to go and major in chemistry for my general one, and then go into med, well, is that a good thing to major in to go into